Okay, here we go. We are going to talk today about AI agents and where we go from here. Talk about an interesting conversation. This is the future of how we are going to be leveraging AI to accomplish more within our organizations. And to kick this off, I'm going to be spending most of the time talking through conceptually what agents are, but then also we're going to do a little bit of a demo of how you go about using agents in your organization to achieve more and understanding of some of the frameworks that we'll be using. And very, very interesting conversation. And just going to introduce myself. I'm Nathan Lesnowski. I'm Concurrency's Chief Technology Officer. Been with Concurrency for 22 years. I've been consulting in AI for about 10. Work primarily with executive teams on how they align AI to the strategy of their business. This is my QR code. You want to connect on LinkedIn, I would love it. I'd love to be talking with you, having more conversations about what's happening within the industry. Also joining me today is going to be Vikrant. Vikrant is a data scientist at Concurrency, and he's going to be demoing a few of the AI capabilities as we have the conversation today. As we dig into this, I'd love you to assertively use the Q&A and chat feature. Ask any question you want, dig in. We have a couple people on this call for that very reason, so we can answer questions as we go and dig into the conversation around AI agents. And as a vehicle to get started with that, I'm going to launch. Amy, you are seeing that QR code, correct? You're seeing my screen?
Yes, I apologize. I was on there. Did I change it to that? I apologize. Did I do that?
No. You're seeing my screen though, correct? Just making sure.
Yes, I am. We see your QR code. Perfect.
All right, good. All right, thank you. Okay, so I'm going to launch a poll, and this poll is going to give me a little bit of perspective of how far this audience has been in the space. Okay, so let's launch that guy. All right, I'd love for all of you to pick one of these options. Just give me some perspective of what you have presently done in the AI space around agents, and even what your perspective or experience has been so far in that domain. So go ahead and launch that. I'll give you about 10 seconds here to fill that out. A little bit of OpenAI, a little bit of LangChain out there. Okay. Okay, that's great. Thank you. Fascinating, fascinating. So certainly the vast majority are nothing but excited. A little bit of you have been playing around with basic OpenAI and retrieval augmented generation patterns, which is fantastic. What this conversation is going to dig into is where we go from here. And this is really where things like LangChain and Semantic Kernel come into play, as well as other models for going down the agent path. So let's talk a little bit about what is an AI agent. What is an AI agent? So an AI agent exists on a continuum. So in the far left-hand side, you can see this idea of a chatbot, right? This is what many people have been thinking about historically in regards to like historical agents. Simple back and forth chats. I need some information about a particular thing. I'm being led through the process of doing a request for a return of a battery I bought, or I have a question about an internal document or a customer service request that's being submitted into an organization. And that is this sort of chatbot into retrieval augmented generation zone that many of you start to have some experience with. One of the things that you might have found in that space is that it's very transactional. It's very memory. It doesn't exist in a sense. Like it's grounded by data. It's grounded by an ability to interact with that data, but there isn't much long-term retention of that conversation. It exists at a point in time, and then it disappears and is no longer something that it really exists as a long-term relationship with that bot or that agent that you're interacting with. And it can't perform, say, long-term activities. It's, I need information on something, it provides that information back, and that's the end of the conversation. Then you start to move into this idea of Copilot, which is this idea that you're interacting side by side on a task, and it starts to, as it moves down that continuum, it starts to have a little bit more memory of who you are. Because it's grounded in a longer sense of data about who you are. So if you think about like even M365 Copilot, for example, like its memory per se of who you are is grounded in the historical basis of your O365 tenant, right? So everything that exists in your email, everything that exists in your body of work is in a sense a memory of its relationship with you, even if you haven't interacted with it much. So it starts to have more than just that one-time interaction that you might have built through a chatbot or a RAG pattern, now getting into this idea that not only is the Copilot able to perform a task, but it has a certain extent of relationship with me over a period of time and can learn from me. Like there's a feature in Copilot that says called Sound Like Me. I'm writing an email, sound like me. And this idea that it sounds like you is built on this idea that it has all the emails you've sent over time. So it can start to create something based upon that relationship that it has with you. But then this movement to the AI agent moves into this fully autonomous sense where they truly can respond to activities, take those activities, perform them, and then bring that back to the person that has instantiated the activity. Think about like even this, and even the fully autonomous sense has a range of capability that exists in it. Think of it like an intern, right? I've got an intern. That intern has a set of capability that I've come to know. Maybe when I first start working with them, I'm unsure about their capabilities. I come to learn it. They become more capable of performing a function, and I start to trust that person to perform action X, Y, or Z, and they become trained to do that thing. Up to a point where maybe you have an architect on your team that is truly fully autonomous and performs tasks that you've delegated to them to do. So there's this range that the AI agents exist in, but think about the context of AI agents as this idea of truly being able to have a self-contained function that has both memory and other capabilities to it. And I'll talk about what those are. So things that an AI agent might do. An AI agent might answer if a client has paid their bill, or it might return the right time for inventory level changes to occur based upon its historical knowledge of the demand inventory forecasting that's happening. It might order inventory based on instructions. So you might get to a point where you're truly delegating an activity to order inventory or to prepare the order of inventory. And that would be more of a Copilot scenario where a person is actively having that perform work that they would have alternatively done, or preparing a client brief for an advisor. I met with a financial firm the other day, and they have all these advisors, and they all do it a little bit differently, and it takes a ton of manual effort. What if I could hand that off to an AI agent to perform that task, bring that prepared brief to the advisor that's aligned to the ethos of the financial advisory firm, that then lets them bring that back to their customers and do it in a way that is aligned to the ethos of the overall firm and combined with the intuition and capabilities of the person, not just kind of trading one off for the other. Maybe it's quality errors in manufacturing, and I have an AI agent that's job is to look for issues coming off the line. Maybe the sticker's not on right. Maybe have you ever bought anything at Costco, for example, where like you got the chicken, you go to check it out, and there's no sticker on the chicken, right? They can't actually check it out, and the guy has to go run across the store to go get it. Well, AI agents can perform the task of doing quality analysis. Now, like, how is that different than like some of the tools that might exist today? And we'll talk about that later. The big difference is its ability to function a little bit closer to the way a human might perform in that task. Memory, the ability to plan out a set of tasks necessary to complete it, the ability to organize itself in an autonomous sense, not necessarily having to always have the human tell it exactly what it has to do every moment. It's kind of like my 6-year-old, when he's cleaning the house, I have to say, go pick up the toys that exist on the ground in the family room. And then he falls on his back and can't figure out what to do himself. So I have to give him exactly what toys I want him to pick up. Whereas my 12-year-old, he can go do that task completely independently. Like, Ethan, go clean the family room. And he just knows exactly what my expectations are. So he goes and does it. AI agents are existing in that same continuum that we need to think about how we delegate to. And that's where it's sort of moving more toward, is this independence that might exist in this space. So you should see in front of you something you should recognize, which is a picture of, if you remember, Star Trek 4. Okay, so Star Trek, I think it was Star Trek 4. Yeah, the voyage home, right? They go back in time. Scotty and Dr. McCoy, they're back in time, and they have to transport these whales in this spaceship to save the future from this like thing that's making these big shockwave sounds. Like, it sounds completely ridiculous at this point to even explain this, but you have Scotty, and he goes up to the computer, and he's gonna like program the design for transparent aluminum, and he says, "Hello, computer." He's like talking to the computer, right? And the guy's like, well, you're insane. Like, this is a mouse. You're supposed to like click on it and type it in a keyboard. And he's like, doesn't get that, right? Because he's so used to this idea where you're delegating an activity to an autonomous AI agent that's performing a task. It's doing it for you. I'm not typing the things anymore. I'm essentially conveying my intent to an AI agent, and that AI agent is performing the task based upon me. And you might say, oh, this is like, dude, this is so far out. No, this is now. Like, these are things that we are doing now. And in a sense, it's the architectural advancement that exists surrounding how you're building AI platforms. And we'll get to in a second, like, people are building AI agents actually incorrectly because they're trying to build too much of that infrastructure themselves. So closer than you might think. That moves as well into, if you remember Star Trek: The Next Generation, you had these sort of situations where Geordi would say, do a level 4 diagnostic on the warp core, okay? And that's a complex set of activities that need to be performed independently, pluses and minuses, checking this and that, all this stuff that has to happen, right? And it's essentially like runs over a period of an hour and a half. But he's told the AI agent to go perform that task. Again, kind of a representation of like, you're handing off something. And in this case, it's still kind of a copilot even in that space, right? They're reviewing the results. They're reviewing the results before something happens. But still an interesting use case or idea. And then the last, if you are also still a Star Trek fan, I'm sorry for all the non-Star Trek fans on the call, but there's this really interesting situation where Geordi has to solve a problem happening on the Enterprise, and he creates a holodeck of the Utopia Planatia Yards, where the designer of the Enterprise is instantiated as a virtual instantiation of herself, which becomes this whole like complicated issue of him doing that. But what I thought was really fascinating about it is he's collaborating actively with an AI agent to solve a problem. And in this sense, it's not just like, go do this thing and return it to me. It was this like very active relationship working with an AI agent to make things happen. So where are we the closest to? Montgomery Scott talking to the computer. Certainly the middle zone, but even more so, I think we're getting close to what was possible with the AI agent of Dr. Leah Brahms. So all that said, this next slide, what you should start to see is, what is the delineation between an AI agent and its capability and what copilots are doing now? So think about like when we think about the execution power or capability surrounding what M365 Copilot might do at the moment, or what a the existing level Copilot might be doing in terms of its ability to take action on a thing that we've given it, or autonomy, whether it's assisted or potentially even full autonomy. Now you think about like autonomy as far as like self-driving cars, or which of course is a huge point of contention and collaboration right now, but it is going to happen. It's going to be something that takes hold as the technology continues to evolve. You don't have ChatGPT flying your plane, thank God, but you do have a autopilot that will take a portion of that flight, and person's hands aren't on the sort of virtual wheel in a sense. Such as ideas around task initiation, autonomous versus user initiation. who's organizing and automating the task. Again, great scenario where AI autonomous agents or even AI copilots, which are essentially agents that are not autonomous, are performing activity within the space. I think one of the biggest pieces here, I'm not going to go through all these, but I think one of the things, the biggest pieces here is ability to handle complexity in a decision-making process, and also a little bit of ability to handle ambiguity that exists within the decision-making process, exists in this space. So all of this is to say that AI agents are a quickly evolving conversation. So give you perspective on a couple key frameworks. And Vikrant, please feel free to come off mute as you have some things to mention here. There's a few frameworks that you might already be somewhat familiar with. LangChain, LangGraph. These on the left-hand side, this is an open source framework that facilitates sort of AI single function agents into multi-agent experiences that allow them to chain together. Very interesting, very open source, a lot of content around it. Great framework. It's one of like I guess you could say like one or major 2 or 3 that are really taking hold right now. The second that you may not have played with, it looks like nobody played with it yet, but certainly something that's like gained a ton of acceleration is Semantic Kernel. About half of the Microsoft Copilots that have been built are built on Semantic Kernel. So that's sort of the inside info. The inside baseball on that is that the companies that have, or not companies, the teams that have the greatest velocity right now are the ones that built on Semantic Kernel. Now, the reason the ones didn't build on Semantic Kernel is simply because they existed before Semantic Kernel was a thing. But certainly is a reason why they're gaining forward movement. Now, one of the things that's interesting is that both of these frameworks have some drawbacks. One example of that drawback is just like, and Vikrant will talk about this, some of the customizability or the way that it handles requests or the extent to which you have your hands on the dials. And that might be a reason why you even build your own framework for doing AI agents. But be very careful if you go down that route, simply because if you start building your own framework, it then is yours. And you're building something that other people are building at broad scale across the industry. And then this last one in the middle here, AutoGen. This is something from Microsoft Research. And I'll talk a little bit about it. I expect most of its capabilities to move into Semantic Kernel versus it being like a product in and of itself. But it's, that's my guess. Like, I don't know for sure. But AutoGen is certainly an output of Microsoft Research, and it's a vehicle to talk about stacked agents that are like talking with other agents and collaborating with other agents. So certainly like a huge point of interest and capability right now. Okay. So this leads us into a conversation about goal-based versus utility-based agents. And this is, I contemplated whether or not to include this or not because it is sort of like pseudo-academic in nature, but I think it's important to think about. You ever heard the term like start with the end in mind? You ever heard that? Many of the agents we're now building, and this is, in a sense, this can be actually a little disconcerting, is they're being based on what am I trying to achieve? What's the thing I'm trying to actually accomplish? And that can be a spoken thing. It can be a described thing. And in a sense, that's also like why this is so powerful, but also so challenging because like if you think about like, why do I like ice cream, like to do triathlons, like what are those things? Like why? Like find that spot in my brain that describes the end game behind that. Very difficult, right? Like even describing that now, like we're starting to understand the brain, but like very difficult. You can think about to a certain degree, like some of the things that are happening in the sort of large language model plus zones, not being directly analogous to what happens in the human brain, but certainly like closer to it than what we did with like demand inventory forecasting traditional models that are very deterministic. Goal-based agents focus on that kind of idea. They're thinking about like, what is the end game and how do I get to that goal? How do I work toward that goal? Utility-based agents don't have that sort of fixed goal in mind so much as they are evaluating against a metric like energy consumption or maximizing profits. Whereas, say, a navigation agent would be, I want to get to point A. I don't actually care about some of the other qualities that get me there. I care about getting to point A to point B. And maybe I care about getting there fast. But getting there fast isn't the metric. Getting to point B is the metric with other qualifiers. So most agents that we're thinking about kind of live in this zone. It doesn't preclude us from thinking about utility-based agents as well. So you'll see a lot of content on this, but I'd be happy to share the deck afterward to kind of let you dig into that very academic conversation, but also very intentional conversation. So what are the components of an AI agent? If I'm building one, now that we got the why behind this, right? I want to have a more effective delegation to an AI agent to perform something or get me something or return information for something, or even more so, like I'm just building like a case management system or a customer service system or a quoting system. Like, how do I do that well? Like, what are the now repeatable components I use to do that well? So components of an AI agent are this. There are plugins or integrations might be another way to think about it. Like, I can talk to different things to return information to my AI agent. I have planners that put together the steps to accomplish my task. And I have personas, like what is the character or the relation, how does my agent interact with you? Is it very static? So if you did your taxes on TurboTax or H&R Block this year, you notice that they have a AI chatbot that exists there. Super static in one of them, not very static in the other. Very interesting how they made this decision. But they both have their own persona, and one is very like dry and one is a little bit more less dry. But they each have their own way of interacting. You have to make a decision as to like how creative is my AI agent and how much do I want it to be coloring outside the lines or not. Very interesting part of the conversation. So as you're thinking about this, there's a couple different ways that I think is fascinating, but it all requires a certain degree of a new mental model. So when you are writing and creating large language model AI platforms, you are finding that some of the things that you might have done before are harder because it's less deterministic. But the flexibility and creativity that exists in this space is incredibly powerful. So you run into limits which can't be done. And then this is what allows us to think about why we need agents, because you need tools that facilitate the AI platform in a way that's similar to partnering with a human, but not a human. Thinking of like this long-term conversation we were having earlier, that like your initial RAG pipeline, short-term, it remembers only that one interaction. Think about what we're talking about here. Infinite chats, long-running tasks might run over days, like activities that need to perform over a period of time or even completely independently, but I'm just monitoring it. How do you do that well is the big question mark. This is really what we're talking about. It's the architecture to do that well. So one thing we're going to use as an example for the following content is semantic kernel. Now, again, this isn't the only way to do this, like LangChain, LangGraph, also a sort of equally, maybe equally is the wrong word, but like a great platform to be thinking about as well. But we'll use this as an example to talk through this topic. What is semantic kernel? It is a open source, lightweight platform for handling agent creation. Its job is to not have us all create the same framework or to create our own frameworks, and instead to facilitate building upon a framework that many can build off of. It doesn't cost anything. It's an open source framework that you can use to be able to make progress here. Microsoft's contributing to it rather assertively, and it's how they build their own copilots. So if you want to know how they build their own copilots, there you are. You're using semantic kernel at this point. So there's a GitHub repo, there's a Discord community. You can get right in conversation with the product team as a result of that. If you want to dig in, or if you want to know how we're building things, this is certainly part of it. So what does an agent contain? This is a big question, quite a bit. So the first thing the agent contains is context. It exists in a space that's specific to its goal. We'll talk about like purpose-built agents in a bit, but like just think about the idea that like agents are a lot like people in the sense that like they have things that they do better and worse, right? We know that like if you just go out to copilots.microsoft.com or ChatGPT, its ability to perform a task might be not as excellent as if I gave it specific grounding to do that task really, really well. It's accuracy and precision at that specific task. But then also the shared capabilities can provide some broadness as well. But what if you've been following any of the sort of recent Microsoft conversations, is that even small models can perform roughly equivalent to large models if their training data is excellent training data. So there's a lot of forward movement in what's happening there. So the first thing that this contains is the context itself. The second thing it contains is recallable memory. Now, think about, recallable memory in the context of both short-term and long-term memory, right? This idea that like stuff exists that I've been doing over a period of time, but then also potentially long-term recallable memory. We'll talk about what that is. Funny that we're like short-term memory, long-term memory. Does my AI agent have memory loss? Like we'll talk about this. There's an ability to create a plan. More sophisticated people have more sophisticated abilities to build plans, right? Like kids ask me what we're doing. Go to the clean up the house example. Every Saturday morning, I sit down and I write on this little chalkboard like everybody's jobs for family cleanup, right? So-and-so is cleaning the garage, so-and-so is cleaning the basement. This is the vacuuming jobs. This person is cleaning out this thing. Someone has to create a plan, right? So AI agents become capable of creating plans. Simple RAG pipelines do not have this. First off, they don't have recall memory to a large degree, but they also don't have the ability to create plans, at least in a way that they do anything with it. Then you have interactions with other parts of the platform through APIs. You have functions that are built for out-of-box plugins, and then you may even build your own custom plugin that exists in that space. So and a sort of another picture of this idea is let's pretend that you have built a agent that facilitates sort of long-running customer service questions and answers and activity that needs to get researched. And you probably built a front-end experience, whether that's like a Teams chat or it's an application experience that lets you hand things off to that. Go research this, find potential answers, bring it back to me. A funny thing is it happens so fast that like maybe you don't even, it's not even a long running task, but like you have this front end that exists and it does things with it. What's happening is you're then invoking that into the AI service, and it is selecting the actual tasks that need to happen. It's selecting the model, the simple templating it, and it's rendering a set of prompts. But this is a cyclical process, and this is something I want everybody to get, is that like once you enter into a semantic kernel, it's like a gigantic while loop. Okay, I think like it doesn't stop doing what it's going to do until it is completed your task. And that might mean you have an integration with outside things like an AI model from OpenAI or something from the Hugging Face Hub or something you built yourself that's getting ingested and used to return results back to the application and parse. It functions as a model to do these things. So like you could build all this yourself, or you could leverage semantic kernel or something akin to it to be able to accomplish these tasks. So I mentioned I was going to talk about memories, misty colored ones. You have this idea of agent memories, and we have different vehicles to make that happen. So for example, you might have long-term memories that need to exist. And this is what we call a vector database. So you might use a custom vector database that you built yourself. So think about, you're positioning a Cosmos database. That Cosmos database contains data. You're building an ability to look up data within that platform. You might even have it query business system data when it's asked certain questions. It might not even be like one of these things. It might be like, call this business system, return this information that I can then use as part of what I'm trying to solve. Okay, so like your agent memory interaction might be something to that degree. It might be something that complicated, where it's like, I'm not going to take that from my business system and putting it into another database. I might be like actually calling that source of truth to return information back. In a sense, that is the memory of like what you're asking for, right? But even in addition to that, like it has its own memories of itself. Like it's I'm not trying to persona like make this into a human analogous thing, right? But like think of it in a sense of like its ability to retain information based on historical conversations that you've had, or even ways that this has been successful in the past to be able to make it better. So you might build your own integrations or your own databases, or you might use Azure AI Search, which for the most part is like where a lot of companies are going, which is essentially is a vector database optimized for cost and return results that gets connected into your AI agent. So this is a little different, by the way, than like just what a standard RAG is. Okay, so a standard RAG uses Azure AI Search too, but it's doing so only to return information. This is also, you're also thinking about memories here in the context of like other long-term relationship data that you have about solving problems or about the interaction. So the goal of AI agents is not simply to like just have that data on hold in a stateless way, but to maintain some kind of state regarding the relationship with the end customer or user of the system. So super interesting and certainly part of the framework. So how does that work? Like in practice, you are combining that with plugins. So plugins performing certain tasks, and that might mean your application. It might mean M365 Copilot, and this is why this is all contiguous, right? So like you might be interacting with M365 Copilot, and then it's providing a relationship to Semantic Kernel or back and forth, and having this ability to tie in. So pausing here for a second, I think you're going to find like there are varieties of ways to do additional work. So things like math, right? So like in Semantic Kernel, we all know that like large language models aren't good at math, right? Neither am I, but let's just take that as it is, right? So like I hand that off to an action, it performs that action. So how are we solving for that? Well, there's a plugin called Math Plugin, or you can build your own or use any set of other capabilities that you've tied into to perform mathematical operations on something that needs to be done. Or you might hand off to another agent to perform that task, which makes it super interesting in that context too. So this is something that's going to continue to expand. In full transparency, LangChain, I think, has done a good job of having like a bigger variety of plugins at this point. But I think Semantic Kernel is a little bit better organized in terms of how it attacks the problem, and will probably gain velocity kind of in the bigger space long term. So also integrated into this is the idea of planning. So like you talked about like making this sort of job cleanup board for the home. Like your agent is going to have a planning capability. So like there's a capability in Semantic Kernel called handlebars. Handlebars essentially give your agent the ability to provide, here's the wall, here's the like how I want you to stay on track in a sense of like what handlebars mean. So this is like a prep for how it's going to create its plan. Okay, so like interesting thing about this is it's all English language. Or isn't that funny? Like keep templates short and sweet, be efficient as possible. You're describing this in a way which isn't like a mathematical formula, although it is behind the scenes. You're essentially describing what it is that you want. And this is different from the prompt. It's not the system prompt. This is something else that goes along with the agent plan. So then what happens is when it builds a plan, it is constructing this output that you can export and understand what was actually built as the plan, right? So when you ask a question, go, do this particular thing. What it's going to do then is it's going to create this plan in front of you. If you ever, actually, a way you can see this, if you go out to copilot.microsoft.com and you ask it to solve like a simple mathematical question, like I've got $100, and if I put that at 10% year over year interest, what's the what does that $100 turn into over 20 years? Like, and you'll notice what it does is it takes that information and then it actually kind of like outputs the plan of the math of how it's going to do that. And then it does that math in that interface. This is very similar to like what happens here, except you're in a little bit more control over the actual planning process. Okay. Another thing that you would be doing as you're building an agent to perform any task is to give it a personality. In a very like non-human sense, like but it still has a way of interacting. And this is also similar to a system message, except it's not the system message. You're indicating how do I want it to perform? Like in a sense, it is a system message, but like, how do I want it to perform? You're a friendly assistant who likes to follow the rules. You will complete required steps and request approval for taking consequential actions. You're giving it, like, again, a human sort of intent. This is also why people can sometimes be uncomfortable building agents because it's like, wait, like, how do I set boundaries? Then you can put like guardrails around these things. But again, you're describing it in a human-centric way, which is also, again, fascinating. But another part of what semantic kernel and how you go about doing it. So before we get into Vikrant demoing a few things, I would love to talk about now how this all relates to multi-agent frameworks. So what you can think about in terms of multi-agent frameworks is I might have an agent that performs a task, but perhaps I have agents that are skilled at certain things, and I start to hand off tasks between agents that perform those activities. So semantic kernel can be built to do that. So can LangGraph, and AutoGen is like sort of the master Microsoft research project around this concept. And at the end of the day, its goal is to, and this is, I don't know if this is scary or interesting, but imagine you have an org structure that's made up of roles that are all AI agents, and I'm essentially delegating to a AI agent that performs a task. So, in a multi-agent framework, you might have a user proxy agent, which represents like a shell of the relationship with the person, okay? But then and that's who's like interacting with the person, okay? But then this user proxy agent is actually interacting with an assistant agent to do the thing. So you can see here, right here, we have the interaction with the person. But then from that, all these other steps in between are this interaction relationship between the two, which then brings back, so this is the output, brings back to the person, and then that gets handed back to the agent. So really what the point of this is to say that it's not as simple as like a person just interacting with an agent that solves every problem, right? It's going to become a human that interacts with the user proxy agent, then goes to the agent that actually is good at solving that problem. Essentially like a project manager agent in a way, like you're delegating it. Again, you're like, is this like light years out? Like, no, this is something you can do now. Like this is something that you can intentionally build your structure, how you're building your scaled model around. So then you start getting this point of like agent organization. I have a conversable agent, and then it's handing off to different hierarchical pieces of the picture, or even joint chatting. Like, can you imagine a situation where like the generic customer service agent pulls in the like product specific agent into the chat to have the conversation? Why? Well, the reason why is because we have a lot of different functions within our businesses, and they need to work correctly. Like none of this is a big deal when it comes down to things that don't matter. But when things start to matter, they need to be precise and accurate. And if you are building something to be precise, you want to be able to test it, validate it, know it's going to be successful. And that means you're probably not combining like the lunch menu chat application with the customer service chat application. They're two different agents that perform very specific functions that need to be tested. But you might have a conversing agent that sits on top of the two to route you to the right place and pull in the right place, put right agent to perform the right job. So you say, computer, what am I having for lunch today? Or computer, my customer has this question. Like, both are theoretically routable, right? I don't have to have necessarily even two, separate places to go. So an example of this might be, help me write an email for my boss. Of course, I would be happy to help you write email for your boss. Would you please provide me with details? Specifically, I need to know. Note this is interesting. Most LLMs don't do this right now, right? Like this, note what's happening here. It's asking for more information. Most of the time when you go to ChatGPT or copilot.microsoft.com, it doesn't ask for more information. It just says, here's my answer. And you are left to adjust it. In this context, remember the big while loop, right? It's knowing I don't have enough information to solve the problem. It's developing a plan. These are the things I need. Go back to the person to get the information and then go take action on it. So you see then the relationship to what the user is then doing with that information, saying, here's the things I need you to do. Great. Sounds like a great topic for an email. Of course, this isn't what we necessarily would use an AI agent to do, but like I think it's an easy thing to follow. Okay, here's the boss's email address. Great. Here's the plan. Okay, so like these are the things that we need to have in this email. Does that sound good? Yes, please. Okay, cool. Here is the draft, and this just continues like into the draft of the email. Think about that in terms of solving any problem that an AI agent would receive. Can you help me do X? Sure. Here's what I need. Here's the information that you need. Or go retrieve it from this business system. Return it back. Does that look good? Note there's human in the loop. The reason human's in the loop because maybe you don't trust the AI agent to do this completely independently. I might not either. So we need to have this sort of back and forth that might exist, but certainly was faster than doing it myself versus doing it as a part of doing everything else. Okay, so I love to have Vikrant talk a little bit about some experiences that he's had working with Semantic Kernel and like positive, negative, like let's just be raw here. Like this is totally an evolving space, something exciting that's happening. Vikrant, give us a little perspective here about what you've seen with Semantic Kernel so far.
Yeah, thanks, Nathan. Awesome conversation going on here. I love the fact that there's so many people excited about this space. Overall, here at Concurrency, as part of the data science team, we've delivered quite a few LLM-based applications. Here's my perspective as a developer and a data scientist in terms of semantic kernel. I mean, this is totally just my perspective because again, we all just saw that semantic kernel has like three main components, right? Like you have your kernel, you have your plugins, which are like individual components that your kernel has access to, and you have your overall planner or the controller. So that's basically like the product manager that you just spoke about, who creates out a plan and then just performs like different actions to accomplish a specific goal. So just restating for brevity, an agent is basically just an automated flow that is intended for, let's say, sending emails, retrieving information from a database, asking for help, or just retrieving memories from previous conversations. So like having its own memory as part of your application. So again, moving ahead with the pros, there are definitely quite a few. Mainly, you can create your own plugins. If you think about it from an engineering perspective, it's going to be like a REST endpoint that you can connect with your ChatGPT or Bing search application. Amy, if you could move on to the next slide, I think that's where I am at right now. Yeah, thank you. Yeah, so again, each plugin could be deployed onto Azure as an Azure function with a specific REST endpoint that you can just push into ChatGPT or Bing search. So in order to have like a well-developed chat application or like any LLM application, you're going to have these agents that are going to be interacting with different plugins, right? Like, and there are VS Code extensions that help you accelerate through this process. So it automates a lot of the boilerplate stuff that you might have to run into if you're developing these on your own. Again, going over into the plugins themselves, they're going to be two types. So one being it's either a native function, which is written in Python, Java, or .NET, or it could be a prompt itself that helps you generate out content as per your requirement. So think of these as modular components that you deploy onto the cloud and then just use them in your application. Now, the planner, which is what I was talking about earlier, being the product manager or like the manager who decides what plugins to use at runtime based on the user's requirement. Under the hood, it's a very well-defined prompt that chooses a set of plugins to use at runtime based on what the user's ask is. So according to the goal, let's say you have provided 15 different plugins or like 15 different functions to your kernel. At runtime, when you ask it a specific question, it's going to say, hey, I think based on the descriptions that you've associated with these functions, I think we should use, let's say, these 1, 2, 3, 4 functions in this sequential order, or like just a specific order that's been defined by researchers. I mean, it's based off of like MRKL and React. So MRKL being modular reasoning, knowledge, and language, and React is reasoning and acting and language models. So it's all based off of research, but under the hood, what I mean to say is it's a prompt. It's a prompt that's going to access things that you've written in code, but convert those into strings and then ask another LLM to generate out this plan. So a lot of pros here. I think we can move on to the next slide. Yeah. So again, like with every package or application out there, there are obviously going to be some cons. So again, the robot there is just to denote that you might run into some facepalm issues, but again, it truly depends on the kind of user experience that you want to give to your application or your clients. Because again, I've noticed like 3 different things in terms of the cons. One being there were some source code issues as part of the starter documentation itself, like the starter demos that they have out there. Going through like the open GitHub issues, I just saw that we had to fall back to like a dev release and then roll back my Python version. Whatever, that's all fine. But I'm just thinking maybe there might be some debugging required in practice when we actually deploy these production grade applications.
Mm-hmm.
That is also to say that the planner itself, although it is based off of research, like I just said, MRKL and React, it is a bit just like a very highly fine-tuned prompt that someone else has written out for you. So it is a bit non-deterministic, and it might run into some issues when you actually deploy these production-grade applications. We have done this in the past where we use like router or like Llama index to create out like a specific set of flows, and we had explicit control over these flows. So that is to say that we had intent detection routing to deterministic agentic business flows thereafter. So you have one entry point, you basically define what intends to be detected for that entry point, and you have 10 different flows that actually are agents in their own right. So in production, if you're dealing with this kind of application, I've seen that debugging these can be better done, and you're going to be able to have more granular control on what you need to improve. So it's a very elegant balance between both. But yeah, overall, I think it truly depends on the kind of user experience that you want to give to your users. And finally, I just noticed that there's not any direct usable functionality for Pydantic. So we had used this in the past as well, which was if you want to enforce out like a specific structure to your prompt response that you get from an LLM, it's going to get tricky because LLMs by default, it's hard to put the reins on these horses to say. It's tricky, but it is doable through like very well curated prompts, and Pydantic essentially under the hood does this for you. So up until now, at least at a first glance, I haven't seen a direct support for Pydantic, although it uses Pydantic under the hood. But yeah, that's basically what I've gotten into right now. Hope that helps.
Awesome. Did you want to show anything, Vikram? I wasn't sure if you actually wanted to review that.
Oh, I don't really have like a working application just yet, but yeah, I've been playing with it just on the sides.
Yeah, cool. Okay, I overextended the term demo there, so I'll back that down. Okay, last thing that I think would be interesting before we start to break is some of this is going to come into like think, oh my gosh, like I don't have, let alone do I not have data scientists, but I don't even have like developers that build these kinds of things. This is going to be a very rapidly evolving space, and one thing that's already happening in the RAG zone for these sort of middle zone kind of use cases is low code, no code, semi-code kinds of scenarios being built into, and I'd love, Vikram, in a second for you to kind of comment on how your experience is with some of this too. This isn't to say that like everything's going to be built in low code or semi-code. It definitely will not. But there's a lot of scenarios where things that were harder before are now becoming productized to a level where you can build this with highly capable power users rather than having to have like all the sophistication built. So like, I think what you're going to see is that you may not even know semantic kernel or like LangChain is operating underneath the covers of something, but the framework, the platform you're using to build it is doing so and using a lot of the same concepts. So this is a screenshot of Copilot Studio, and Copilot Studio is like a low-code way to build medium of the road AI chat experiences, or what they will eventually call agents, in the context of this. And what you can see here is I'm part of this organization called the Catholic Ecology Center. We have this building that we're working on, and I pointed at the website. You can add in these like development, you can upload documents or point at a SharePoint location or whatever. And very quickly, you have a chatbot that is successfully answering very specific questions about that organization and surfacing where that information came from. This has also been used to say, take action, right? So like we built, Vikrant and team built a chat experience where go order this laptop or go take action on this thing. And at the moment, it's very short-term memory oriented, but long-term, I would expect that like additional investment gets placed in this kind of space as well. I don't know, Vikrant, you want to comment on what you're seeing with some of the low-code tools as well? It's sort of like that the agents are for everyone, I guess is my point. That like agents are not just a thing that like we're going to construct in a development house, like they will be, but you'll see these light up in a variety of places. Vikrant, what's your perspective on that?
Yeah, I totally agree. So this space has been so rapidly evolving right now over the past few months that I know the last year is where we've seen the most development in terms of building out LLM applications with accelerators like Semantic Kernel or Llama Index or LangChain. But overall, I do see value in this low code, no code kind of Copilot UI where you can just build out a chatbot that does 10 different things very easily within like a few hours if you have the right training for using that UI. But again, the fine-tuning aspect of things is something that they allow you to do through UI. If you prefer like a code approach, that's when you want to kind of build out your own chatbot using LangChain or like Llama Index. So the UI aspect would be good for maintenance with like very quick fixes. But if you want to fine-tune and dig deeper into why something is happening the way it is, that's when you would rather choose a code-based approach. That's what I think.
Awesome. Okay. So where we go from here, what we would love to offer is to have some conversations with you. One of the things we've done, I think we've done probably 40 of these executive sessions for the sort of leading executive teams through the process of adopting AI. We can also dive into use cases in the context of something you specifically are building, or company-wide envisioning sessions, helping with hackathons, getting you off the ground. So there is a form that I'd love you to complete before you leave. And my intention with that form is for us to have a conversation with you about one of these options. So either diving right into the executive conversations, understanding your use cases, or creating excitement and engagement by driving envisioning and hackathon activities within your organization to help you to fish, help you to build. And I think that's one thing that we feel really strongly about, is that our goal is to help you accelerate your business and your mission using AI. And that has a lot of different ways in a lot of different organizations, but it's a great opportunity for us to be a great partner for you in that sense. So pull the trigger on that. We'd love to have that conversation. And then, and also in that context, connect with us on LinkedIn. We love talking in the community. This is just a passion of ours. It's not just about, it is about like also connecting businesses, but it's also about raising the general understanding of where AI is going within the greater ecosystem. And connect with us to get this regular content. Every single week I produce a newsletter on AI. So definitely connect with us and have more conversations as well. So nice to meet you. Thank you for joining today. Please fill out the survey at the end. Tell me if you loved the session, or if you didn't, tell me what you want to change. And we'll see you next time. Thank you very much.
Thank you.